VC Chemistry, Unit 4, an overview of spectroscopy. So in this session, we'll briefly talk about IR NMR and AAS and UVS, see how they are connected, and we'll also talk about mass spec, which is not really a spectroscopy, but it functions as a very important instrumental analysis technique. So first of all types of spectroscopy, if we call something a spectroscopy, then we are basically using electromagnetic radiation to analyze it. Okay. So here is basically a part of the spectrum that we commonly use. So you will see that once we go from left to right, the wavelength, basically all electromagnetic radiation is basically waves with different energy. So the wavelength as we go towards the right becomes shorter and shorter. That means the energy of the waves becomes higher and higher. Okay. So going from left to right on this particular spectrum, we can see an increase in energy. Okay. So different radiations comes with different energy. Therefore, when they go through a particular substance, they will interact with them differently. So we formally learned about AAS and UVS. Okay. AAS is more like a flame test. So it's called atomic absorption spectroscopy. It's basically the electrons in an atom absorbs energy mostly from the visible light spectrum, so these wavelengths, okay? And then they absorb energy, they jump to a higher level. When they come down, they release that exactly the same amount of energy that they absorbed before. And since they absorb energy from the visible light, when they give out that energy, we can see different colored lights. Okay? So AS is electrons absorbs visible light and jumps up. When they come down, they will release that energy so we can detect it. And of course, you will see that different atoms have different electronic configuration, and therefore they will absorb different amounts of energy, jump to different levels, and gives off different colored lights when they return. UV-Vis, we are still using mostly visible lights, and sometimes we go into ultraviolet spectrum, so higher energy waves. So a particular ion in a solution can absorb energy from these spectrums, so visible light and ultraviolet region of the spectrum. And based on how much energy they absorb and what particular wavelength of energy they absorb, we are able to determine what substance is there or what ions are there. And secondly, we are able to determine how much there is actually in that solution. And therefore, UV-Vis can help us not only determine what ions are there, but also what concentrations they are. In Year 12, Unit 4, we need to learn about two new spectroscopy. One is infrared radiation. So basically, by name, you know that we're actually using the infrared part of the spectrum. So what actually happens is that because it's lower energy waves, the energy is only able to interact with the bonds in the particular molecule, not as to the atom itself. Yeah, just the bonds in the molecule. And different amount of energy will make different kind of bonds. They bend or they stretch. Okay. So we're not really breaking the bonds. The energy is not high enough to break the bonds. We're just making the bonds bend and stretch. And that bending and stretching will consume energy. And based on how much that energy is consumed, we're able to determine what kind of bonds are there. Is it a carbon-carbon double bond? Or is it a carbon-oxygen double bond? Or is it a carbon-carbon single bond? Stuff like that. Okay? So using IR, we're able to determine what particular functional groups are there in an organic compound. NMR is even lower in energy on the spectrum. So they only have enough energy to make the nucleus flip in a magnetic field. And lastly, mass spectrometry. Okay, so it's no longer called a spectroscopy anymore because actually mass spec does not use the electromagnetic radiation. That's why it's not called spectroscopy. Okay? What we use in mass spec is that we actually use beams of electrons, and they're quite powerful. So they are able to bombard the sample and break apart the molecule. So when you put a molecule through a sample of molecules through mass spec, they're actually broken apart into different segments. And different fragments, because we're using electrons to hit them and break them apart, you can imagine that different fragments will sort of like carry charges more or less, right? So electrons hit electrons, they either kick off an electron to make you have a positive charge, or they sort of break you apart and one part will have more electrons than the other. So different fragments will carry charges as a result. And then those ions are able to be separated. So some of the fragments, if they don't have charges, they can't be detected in mass spec. But all the other fragments that have charges can be separated in a magnetic field based on their mass, or actually, to be more accurate, a mass to charge ratio.